This is the next part of section 1.7. We're going to solve this equation for x, and the equation reads the absolute value of 2x plus 5 is equal to 3x. And so we do the same thing we did before, which is we split it up into two different equations. And those equations are 2x plus 5 is equal to 3x, the positive one, or 2x plus 5 is equal to negative 3x, the negative one. And then we go ahead and we solve each of these equations. And then you're going to do the same thing you always do, which is you're going to combine like terms. And the first thing I do to combine like terms is I'm going to subtract the 2x from this side to cancel it out. Subtract the 2x from this side. And now I get 5 is equal to x. And there you have it, the solution to that one, x equals 5. And then on this side, I'm going to do the same thing. Subtract the 2x to get rid of it from here. Subtract the 2x. And I actually get 5 is equal to negative 5x. And then just going to solve for x by dividing out this 5 to get rid of it, this negative 5. And then also divide the other side by negative 5. And you get x is equal to negative 1. So now, the same way as last time, I have two solutions. I have x equals negative 1 and x equals 5. But the tricky thing about problems like this is you always have to plug it back into the original equation to check it, because sometimes one of these solutions can be extraneous. And the term extraneous here basically means it's an extra solution that isn't a real one. It kind of just came out of the inequality. And so you have to plug it back into the original, came out of the absolute value, and you have to plug it back into the original equation to make sure that it's a real solution. So we're going to do that, and the original equation is the absolute value of 2x plus 5 is equal to 3x. And so the first one I'm going to plug in is x equals 5, and that's absolute value of 2 times 5 plus 5 is equal to 3 times 5. And that basically gives me 10 plus 5, the absolute value of that is equal to 15. And I know that's right because the absolute value of 15 is equal to 15. So that's right. So we know x equals 5 is a real solution. It's not an extraneous solution. But now let's plug in x equals negative 1. So the same way, absolute value of 2 times x, which is negative 1, plus 5 is equal to 3 times negative 1, which is x. And then you solve that one and you get negative 1 plus 5 is equal to negative 3. Whoops. And then on this side you get the absolute value of 4 is equal to negative 3. And is the absolute value of 4 equal to negative 3? No. The absolute value of 4 is just 4. So this is wrong. And so now we know that x equals negative 1 is an extraneous solution. And all we have to do with the extraneous solution is not included in the answer. So that gets eliminated. And the only answer to this problem is actually x equals 5. And so just a quick review. For this kind of problem, you split it up into the two equations when you see the absolute value. So the negative equation, which is 2x plus 5 equals negative 3x, and the positive equation, which is 2x plus 5 equals 3x. Then you solve for x like you always do, and we got two answers, x equals 5 and x equals negative 1. Now there's the extra step of plugging it back into the original equation. So we plugged in x equals 5, and we got the absolute value of 15 is equal to 15, which we know is true, and so we know that x equals 5 is a good solution to this problem. And then we did the same thing to the negative 1. We plugged it in, and we found that the absolute value of 4 is not equal to negative 3, And so this solution gets eliminated because it's extraneous. So you always have to go back, plug it back into the original equation, and eliminate all the extraneous solutions.